So I've just had to deal with somebody objecting to my quantum gravity idea on the last video that I posted, the video about the red shift and the blue shift. And their objection was focusing on this idea that line of sight would be eliminated, that we wouldn't be able to see anything in the universe if a cloud of electrons was, mediating the force of gravity and photons were traveling through a cloud of electrons to reach us. They were trying to say that photons, would just be scattered off at random and that they'd be going in all different directions in the universe and it'd be chaos. And the way I responded to this was by saying that you need to think about how photons travel through different mediums. So, for instance, when they travel through water and the air, they travel through water and air at lower velocities than they travel through the vacuum of space, so they must be interacting with the particles of air and water. And when they travel between particles of air and water, they are getting absorbed by electrons, and then a new electron is taking that place and emitting a photon again. So between every point in, say, a medium like air, where it's traveling between particles of the background of air or whatever, the photon is getting absorbed and another electron is re-emitting a photon. So this is how you kind of resolve the trajectories of quantum particles in these kind of backgrounds. And it's very, very complex and counterintuitive to think about these sorts of things, since we're invoking quantum mechanical notions and we're thinking about this within the context of non-local realism, and we're trying to understand that, reality is not locally real. So it's not as if all the particles are just staying in one place and, um, kind of nothing's really static ever. It's particles constantly tunneling all around the universe. And, the photon travels from an electron where it's been emitted to an electron where it's going to be absorbed. That electron disappears, goes off to somewhere completely different in the universe, gets replaced by another electron. So, the universe is not locally real. And it's a highly profound insight to try and wrap one's head around. And I know it's incredibly difficult. I mean, I've tried to film this little video a couple of times already, and I keep stumbling over my words and stumbling over my concepts. But and maybe I don't understand it all that well in the context of non-local realism. But I know that when light travels through air or water, it is getting absorbed by electrons in those mediums, and it is being re-emitted, and those mediums are re-emitting photons again, which travel in roughly straight lines so far as we're concerned from a classical physics perspective. And yes, it does seem it's very hard to wrap your head around those sorts of things, but the reality that emerges from that, this emergent picture of reality that we get, is cohesive, and nothing about air or water causes electrons to go scattering off into random directions and therefore eliminating line of sight and causing this scenario in which you're unable to see anything. So we can surmise from that that the vacuum of space really isn't all that much different, and that photons still propagate through it, through this background of electrons, and we can still see things perfectly fine. They still resolve into this roughly straight line of a photon moving through space, albeit with this sort of jagged wave-like trajectory where it's actually moving between the different points faster than light. But it travels from, say, an electron, emitting it, to an electron absorbing it faster than light. Then the electron that absorbs it disappears, replaced by another electron, emits another photon. That likewise travels faster than light to another electron, and so on and so forth. And that's kind of, from my best understanding of quantum theory, let's say that's, I think, the most rational picture that we can derive from the whole sort of mess that it is, I grant you. But it's a mess that resolves itself into something sensible and into physics that we understand very, very well, such as classical physics. And it does resolve itself into a picture that has cohesion to it, in spite of all this quantum disorder, randomness, and counterintuitive stuff that's going on at at the very smallest level of reality, but which nonetheless, in a decoherent universe, produces reality that we're all familiar with. So yeah, that's just one objection that I've had to my theory. I've had others. I've had others which are like varying degrees of sensibleness to them, I think. One person was trying to say that if it's a cloud of electrons, all the electrons would repel one another, and that would rip the universe apart or something like this. And I had to respond to that one by saying that, well, we know that clouds of electrons exist around atoms, so if you've got an atom with a lot of electrons around it, like a uranium atom or something with 236 electrons or whatever it is in quite a small space, which is the charge radius of a uranium atom, then the electron density radius of of a uranium atom, um, that's not causing the uranium atom's electron cloud to drift apart. So, I think electrons, yes, are still a good candidate for gravity particles. And there should be a drinking game, obviously, for every time I say the word electron in these videos, since I do say it really quite a lot. It's awful, I know. But thank you for watching this video. I love you lots as usual. Bye bye bye. See you soon with more great content, I hope. Bye.